Alright, so this video is for electron configuration. Remember, with electron configuration, we're worried about the s orbital, the p orbital, the d orbital, and the f orbital. So that's the order of the orbitals. Remember that this is groups 1 and 2. This is groups 13 through 18. This is groups 3 through 12, so your transitional metals. And this is the bottom two, so your lanthanides and actinides. So those are your different orbitals that you're dealing with. Remember, when you are writing out these orbitals, your goal is always to end with a p6. A p6 means that you have your full octet. It's not octet. So it means you have your full octet and everything is fully balanced. You've reached the noble gas center. So 1s2, 2s2, 2p6, you have your full octet. Whereas 1s2, 2s2, 2p3, you are still three short of your full octet because you want this 3 to actually be a 6. So, not that hard to keep track of, not hard to remember that. Once you have that 2p6, you will no longer react at all. Because you have your octet. You are essentially a noble gas. So with that noble gas, you are not reactive. It does not matter what we pair you with, you're not going to react because you have all your electrons. Life is good. You're not worried about it. The other thing with electron configuration is when you're dealing with the different chemical numbers. So I'm going to use indium a million times because it's easiest. Why? Because it's on the quiz that you just, or the study guide you just did. So because indium is a transitional metal, it can have, hang on, alrighty, I'm back. That was my clock, I apologize. So, because indium is the way it is, and it can have 4 charges because it is a transitional metal, we have to remember that indium 1 has a +1 charge, indium 2 has a +2 charge, indium 3 has a +3 charge, and indium 4 does have a +4 charge. It changes based on how it works. There's a lot more to it with transitional metals on why they're able to do these different charges. Not relevant to you guys, so I'm just going to leave it as they have that ability, so yay, go for them. Remember that when you are doing these, going back to the orbitals and less about indium, when you're dealing with these compounds, so like sodium chloride, both of them are trying to become a different noble gas configuration. So they want to become, for example, I don't know if this is accurate for these two, neon. So neon has, I'm going to say 10 electrons, or 10 valence electrons, not 10 valence electrons, 10 electrons total. Sodium has 9, chlorine has 11, chlorine has 9. So sodium wants to give up 1 to go to 10, chlorine wants to gain 1 to go to 10. So that's why they're doing it. They're trying to get the same electron configuration as neon. And that is what you guys need to know for electron configurations. Yay.